Hey y'all, it's Julie the nursing tutor. I got y'all some more drops per minute. I know how you love it. So here we go. All right, I hope you can see. Here we go. So the physician orders, he gives orders to infuse 1,000 milliliters of normal saline at 200 milliliters an hour for dehydration. The tubing drop factor is 10 drops per minute. Calculate the flow rate in drops per minute. So just to remind you, the drops per minute is total volume times the drop factor divided by your time in minutes. Okay, so let's do this one. Now I realize they gave you 1,000 milliliters, but they also broke it down to 200 milliliters per hour. So this is what we will use. The 1,000 milliliters is a distractor. So the total volume is 200 milliliters. The drop factor is 10. And how long is that going in? Over 1 hour, that'd be 60 minutes. Okay, look, the reason we couldn't use the 1,000 milliliters is because it didn't tell us how many hours it had to infuse. So we're gonna do all the math on the top and divide it by the number on the bottom. So here we go. 200 times 10 equals, divided by 60. That's going to be 33.3, and that will equal just a regular old generic 33. Okay, you like it? You like it, I know. Okay, so the physician orders 1,000 milliliters of LR to infuse at 125 milliliters an hour for a post-op patient. The tubing drop factor is 20. Calculate the drops per minute. It's the same thing. This is a distractor. They're giving you 125 per hour, so we're going to use that. The total volume is 125 milliliters times a 20 drop factor divided by 60 minutes. And we're doing the math like an Olympic gold medalist. So it's I hope you can see that, 25 divided by Dookie fart, sorry. Look, I quit cussing one cuss word at a time, and I'm on the S word, divided by 60. And I say Dookie fart, and it works. So that's 41.6, which would equal 42 drops a minute. Look, boom. We saved another one. Look at that. Okay, so let me cover these up so you can't see them. And then we'll do the next one. All right, the physician orders 500 milliliters of normal saline to infuse at 175 milliliters an hour for a patient with vomiting. The tube and drop factor is 15, so calculate the rate. Same thing. You're not freaking out. You hear me? You're not freaking out because 500, that's a distractor. You're going to be a nurse. They got to know that you know, I don't need that. I just need that right there and that right there. So the total volume is 175 milliliters times a 15 drop factor divided by 60 minutes. Now look, some people will put another fraction over here on this side, but I have a fear of fractions. If you put two fractions, I don't know whether to find a common denominator or to cross multiply. So I just don't even worry my pretty little head about it. I put it all on the top, and we do all that math and then divide it by the number on the bottom. 175 times 15 equals divided by 60. And that's going to be 43.5, and that will round up to 44. Boom. We saved another one right here in front of everybody. Yes, we did. Okay, the physician orders 100 milliliters of half normal saline to infuse at 90 milliliters an hour. The tubing drop factor is 20. What you gonna do? Once again, that's a distractor. Our total volume is 90 milliliters times a 20 drop factor divided by 60 minutes. You're going to be like, bring me a drop per minute problem, Ethel. I'll show you how to work it, sucker. Divided by 60 equals, that will be 30, look, 30 drops per minute. We saved another one. Yeah, we did. Okay. Number 5, the physician orders vancomycin 500 milligrams and 250 milliliters of D5W daily to infuse over 2 hours. The drop factor is 15 drops a minute. What are you going to do? Okay. So, our total volume, the 500 milligrams, is a distractor because this problem is dealing with the fluid of it, not the milligrams. And so our total volume is 250 milliliters. Our drop factor is 15. And it's going in over 2 hours. Well, you know 1 hour is 60, 2 hours would be 120. If you're not sure about that, use your calculator. Don't trust your mind. I mean, you know what I'm saying. And then we're going to do all the math on the top. 250 times 15 equals divided by 120. And that's going to be 31.25. That 5 will make that 2 a 3. But that's all it's going to do. And so you can't give 0.3 of a drop. So it'd round to 31. Boom. Drops per minute. We saved another one. Okay. So the physician orders ampicillin 1 gram and 100 milliliters of D5W to infuse over 20 minutes. The tubing drop factor is 15. Calculate the flow rate in drops per minute. So our total volume is going to be 100 milliliters times a 15 drop factor divided by 20 minutes. And we're going to do that math. Here we go. 100 times 15 equals divided by 20. And that's going to go, look, boom. We saved another one. Okay. I hope that helps. Y'all please if you would like more of these, please put more in the comments. If there's another kind of math you want me to do a video on, put that in the comments. Save it. If you're not here yet, you will be. So save it. Share it. Share it with everybody, okay? And I hope it's everything that you ever dreamed of. Y'all have a good day.